right. Okay, so I know I've got too many windows open, but that's fine. Can you all hear me? Okay. Sometimes when I switch screen, okay, let me know if you can't, right? So I can fix it. All right, so functions, right? So functions are probably one of the most important things you're going to be using a lot, right? Okay, can you say earlier? Okay, yeah, sorry. Yeah, so far what we have done is we looked at JavaScript basics, and now we are at functions, right? So today we're going to look at different kinds of functions, specifically arrow functions, function expressions, function declarations, callback functions. Functions are functions, but there are different kind of functions for different usage. And also history of JavaScript is kind of weird. It evolved by creating new things, right? So what we're going to look at them with some structure, and we're going to look at also callback function in detail and some interesting usage for callback function. And if you have some time, we can look at the flex layout. Otherwise, we'll look at next time. Okay. So I think last time we looked at the functions are basically this group of code that you can execute, and it has something called arguments, which you can configure. So same function can produce different results based on the argument, right? So just in case if you have forgotten, a normal type of function is written like this. So there's a function keyword and then name of the function. So let's say if I say add, that's the name of the function. And then there's a parenthesis and there's a curly bracket. And within this add, I can pass parameters, right? So if it's an add function, which means I can pass some values. So let's say num1 and num2. So we're passing two numbers in here, right? And then we can return something. So function takes something and it returns something. It's almost like a black box. Okay, it transforms something. So it takes two things and produce one thing. And returning, basically, I can say num1 plus num2. So let's say if I call this function, so I can say let total equal to add, and then I can say 1 and 2. Okay, this is how I call it. So this is how I define it, and this is how I execute it. Okay, and once I call it, it will basically take 1 and 2 as a parameter, and then it would return total. So the total will be saved in this variable. Okay, and then I can then console log total to see what is the result, right? And I can see there's a three here, which means it's returning 3. Let me actually do the settings here. So behavior, auto updates. So again, I should usually do this so that it doesn't keep updating. I can control it. When I run it, it would update it, right? Okay, what happened now? Okay, so yeah, I can see 3 here, right? So this is a simple example of function. This is called function declaration. Declaration. Okay. Again, it's a one kind of function. Another kind of function is called function expression. The difference between these two is that I can create a variable. So what I'll do is I can create let add equal to, the way we create variable, and then I would say function and it's pretty much the same thing, except this one is a variable. Okay, and it does exactly the same thing. It will return the same thing. It's just written differently. Okay, so you must be asking, okay, why do we have these two kind of functions, right? Well, having a variable, I can use this, somewhere else because it's a variable, right? I could use the same thing as, but this makes much more sense if I want to use it somewhere else as a variable, as an argument to another function or something like that, right? So that's why this is used. But in terms of functionality, there is no difference between these two. They do pretty much the same thing. Okay. This one is saved in a variable, and this one is not. Also, let's call it add one here so it doesn't get confused, right? Because we have two, we cannot have two functions with the same name. So that's for sure. Okay, so also another thing is if it's a function expression, because it's a variable, it has to follow the scope. Remember when we learned the scoping, you cannot call a variable before it's declared, right? Which means I cannot do this. So I have defined this function and I can execute it right after this, but I cannot do this before it, right? Otherwise it would give an error. Let's see this. It would say, you cannot access add before initialization, which is right? I cannot call something that doesn't exist by this line. So it has to be defined first, and then you can call it. All right, so that's a huge difference. However, this guy, function declaration, you can actually call it before its definition, which is kind of interesting and weird. Okay. Let's see what happens. Right, you can see that it was executed and then returned. So that's it. But mostly you will never call it before its definition, so you don't have to worry about it. So I would say you can use either of these. I really don't have any specific preferences. The cool thing about the function expression is that it can transform into, so this is the transition to something really interesting, which is called then arrow function. Okay, again, it does the same thing, but it's just a different syntax. So you have this function with lots of wording, right? So they figured out, okay, how about instead of having saying something is a function, we just create a sign for it. Okay, so let's do this. I'm going to call it let add 2 equal to, and here we don't use function keyword, we just use the parenthesis, and we would just say num, where was this here? Okay, num1, num2. So this is how we pass the argument. And then if I want to return the body, I don't necessarily have to use this way. I can simply just do this, num1 plus num2. If I were to just do it in one line, okay, it's a weird syntax to begin with, but once you get used to it, you will, it would all make sense. All right. So for those who just joined, let me just repeat what I've done. So we are we are learning about functions. Last time we started functions, but now we are understanding them a little bit more in detail, right? So there are three kinds of function. They essentially do the same thing, right? Functions have name. So the first type of function is called function declaration, where you have a function keyword, and then you have a name of the function, which is add, and then you have a parenthesis, and then you can pass some argument. And again, think of functions are like black boxes where you pass something and it transforms something, and then it would return you something back, right? So in this case, I'm passing two numbers and it returns the total, right? So that's my function. The function expression is similar to function declaration, except if you look at the syntax is a little different. We are saving the function in a variable, so that's the difference. And arrow function is similar to function expression. It's a one step to make it even smaller and easier to read, but initially maybe it looks a little weird. Okay, and then there's some other use for this arrow function, which we're going to look at it. Once we look at it, it will all make sense. But if you think of this way, right? Remember I said function takes something and it transforms something. So in this case, the syntax makes much more sense, where I can say, I'm passing this to number, and then there's an arrow, and then it's transforming into this, right? So that, I think it's more visually, you can understand what's going on. You're passing something and returning something. It's almost like a factory, right? So visually it makes much more sense. But again, if I call any of these, it would return the same results. There are some fundamental differences in terms of how they do it, but we're not going to go into it. I think it's for the advanced level. But just remember there's three different kinds of functions. Okay. So that's it. Let me keep a running total for this one so that I can save the syntax at the end of the Okay. Any question on this one so far? Make sure you try this. I'm going to give you a few minutes. Try this out and see in action. Again, they all would produce the same results. They look different. All right. Okay, so now that we know functions, we need to understand some of the things that we can do with it, right? Let's use some examples in terms of what is the power of function? What can we do with it, right? So I'm going to clean this up. Okay, so one thing we can do is, let's say if I have an array, find the total of all the elements, number array. So if I have an array, say, let nums equal to, let's have 1, 2, and 3. So there are 3 elements. I need to find the total of this array. So visually, I already know what the total would be, which is 1 plus 2 plus 3. So I know the total is 6, right? Okay. How do I find this using a function? So again, there are multiple ways to do this. If I use it without function, I would usually say, you remember for loop we did last time? Let well, which is each or element of nums, or you can say num of nums, which means each number, right? So if I console log this, I will get each number. Where's this? Okay, let's run this. Okay, so I get 1, 2, 3. So I know that it prints each number, right? Okay, now what I'm going to do is, in order to have the total, you need a running total, right? What is a running total? Is I would take the first number and I would add it to, this total. So my total is going to be 1. Then I'm going to take the second number. Then I'm going to add it to the total. So it's going to be 1 plus 2. And then I'm going to take the third number and I'm going to add it to the total, right? So what I'll need to do is I would need to define total, and I would set it as 0, right? And then what I would do, I would say total equal to total plus number, right? That's all I need to do. So for each loop, it will keep adding, right? And at the end of it, if I just do console log total, I would get 6. Okay, that's all good. Now let's create a function call. Now that you know how to write functions, let's create a function call I don't know, sum or something. Okay, and this basically takes an array as an argument, right? So it takes nums as an argument and it returns total. Okay, you already know the code. Just transform this into this sum format. So I can call it multiple times. The problem with this code is if I want to do another total of another array, I have to rewrite the whole code, right? If it's a function, I can just use it as many times I like to use it. I don't have to repeat the functionality, right? So let's write the function that does the same thing. So remember, function takes an argument. So it can take an array and it would return the total, right? That's what it will do. I'll give you a few minutes to do that. And just send me a private message once you're done. Remember, practice is a key when you do this kind of stuff. Functions are pretty cool. The way JavaScript functions are, they have actually borrowed a lot of features from a lot of different languages, and they have, you can do same thing many different ways. Obviously, the disadvantage is that you can do same thing with a lot of different ways. Yeah, come on, somebody should be able to get it. Remember, I showed you how to write the functions, right? You just have to create a function called sum, and then you pass the array, and then it should return the total. You already have the functionality how to do this, right? You just have to wrap it around in a function. Anyone? I'll just go until 4:35. All right, somebody, anybody? I think this is a very simple one, right? You just have to wrap it in a function and return the total. That's it. Use a function declaration, which is the simplest form of function. All right. So how do you do this, right? So what I'm going to do is I already have the logic, right? So I'm going to create a function called sum. So let's uncomment this thing out, which basically takes nums as an array. Let's call it n, inside. So it's different from here, right? And then I'm going to just copy it, this whole thing, and put it inside here. So it will have a total, and it will say, we'll call it ns. Let's call it ns So I'll call it ns, n of ns, and n. All right, so we created a function called sum, which takes ns, which is an array, as an argument. It has a total. Then it will loop through the array one by one, item by item, and each item gets added to the total, right? So at the end, we'll get a total after this line. And I would simply do return total. That's it. Okay, I can just remove everything from here. All right, so this is my sum. And what if I want to call this, right? Remember, to calling is pretty simple. You call it and then you pass some array as an argument, right? And then I can say, let t is total is this, right? And then so log t. Okay, I get 6, right? So I created a function that takes an array as an argument and it returns the total. That's it. And it does something in the middle to transform the array into the total, right? Which is the logic. The idea is then if I have another array, let's say let nums2 or something like that. And let's say this is something else completely. 45, 65, and 10, let's say. Okay. And then I can say let t1 equal to sum nums2, right? So console log t1. So I've written the functionality of summing in one function, and I can use it multiple times. I'm using a nums and I'm using a nums2, right? And same function can return different result based on the parameter that you set, right? So it's giving me 120. All right. Any question on this one? All right, you guys are very quiet today. Be curious. Okay, so now that we have this ability to create functions, we're going to look at a different kind of function called callback function, and this is where the fun begins. What is a callback function? What is a callback function? Callback function. So callback function is basically, you remember how we have a function and you pass an array as an argument, as a parameter, but you can actually pass another function inside a function, which is sounds kind of weird, but it's interesting. So let's create a function called calculator. Okay. And usually when you have a calculator, you can do addition, you can do subtraction, you can do many different things, right? So I should be able to create a function called calculator and call it like this. I can pass two numbers, let's say 1 and 2. And then I can say, okay, I want to add them, or I want to subtract them. Okay. Or I want to, let's just use the first character. Well, or we can do something else. But anyway, let's say if I do this, this should return me 1 plus, well, 1 and 2 is two boring numbers. So let's just use 4 and 2. This would give me 6. Okay. Calculator. If I say 4 and 2 and minus, this should give me 2. Okay, calculator 4 and 2, and let's say multiply. It's too lazy to write the whole multiply, but this should give me 8. Right, and then you can do also division. But you know that this should give you a clear idea what we need to do, right? So here we are using the same function to do multiple things. In a way, it's called abstraction. Abstraction is you leave things open, a bit abstract, and then what you do is you implement things based on a runtime, right? Which means this calculator needs to be abstract as possible, which means it should not have any logic for adding or subtracting or multiplying or anything. It should just say, okay, if I pass add, then it should add it. And the functionality add would provide the functionality. So this is actually a function, right? So we're going to build 3 functions: add, minus, and mult. Function add, we already know how it works, right? We're going to say n1 and 2, and this would basically return n1 plus n2, right? We already know how it works. Function minus n1 and 2, which returns n1 minus n2, right? And then we'll have next function called function mult, which will multiply. Okay. All right. So we have created functionality to do something, right? But this calculator is it's a bit abstract. So we can say we're gonna pass 2 numbers to this. Let's say num1 and num2, right? Which represent these 2 numbers. And we're also gonna pass some functionality. We're just gonna call it functionality, or just F for functionality. Just call it F, which could be, this F could be add, minus, multiply, whatever. It could be anything, any of these, right? Which is a function. So the first 2 arguments are numbers, and the last argument is a function. Okay, so what happens? You get 2 numbers and then a function. Do you see? We can actually call one of these inside, right? So you have a function, and then you have
Mr. Patel,
yeah, go ahead.
shouldn't we put function calculator at the top Or does that not matter?
Function calculator at the top.
Yeah.
Over here.
Yeah.
It doesn't matter, right? Because when you create function declaration, the order doesn't matter, first of all.
Okay.
And also, if you, I would not want to do this. I would not want to do this, right? I would not want to do this because I haven't defined all of these.
All right. Okay.
Right. But if you look at the order, I've defined add. I haven't used it yet, right?
Yep.
I've defined minus. I haven't used calculate. I haven't used yet. So I'm using everything here, right? Which means this can have their order, right?
Yep.
Okay. So I got the function, which is f, which could be any of these, depends on I pass. And I'm just going to pass this num1, num2, right? And just going to return it. And this is the beauty of this, right? So I get 4, I get 2, and I get add. I can literally use this, right? Where add is nothing but this f, right? Because I'm passing it. And then num1 and num2 are nothing but this 2, right? And then this should give me 4 plus 2, and I'm just returning it. Okay. So if I run this, well, I'm going to have to put console log around everything. Then only will print. Let's run this. Right? So you get 6, 2, and 8, right? As expected, 6, 2, and 8. If you think of this is I don't know, metamorphism, whatever you call it, f. So basically, if I just use one of these for sake of it, and just gonna console log it. And again, console log, you can use multiple of these, right? So I can say console log. I'm getting what? I'm getting num1, num2, and f. I just want to know what, when I call this add, what are these values, right? If I return it, if I run it, I would get the num1 is 4, num2 is 2, and then f is nothing but the add function, right? So I've got all three. I got the ingredients and I got the tools, right? I got the eggs, I got the salt, and I got the stuff inside. And then I just cook the egg, right? And return the omelet. That's it. So if I pass microwave, I can do sunny side up, okay, or whatever you do with the microwave and eggs. If I pass fryer, then I can get fried eggs, right? So this becomes an abstract calculator where it doesn't say anything about I'm adding or subtracting or multiplying. It's basically say pass me stuff and I'll just use it. And that's why this is called callback function. And callback functions are a function that you pass into another function. Okay. So f is a callback function here. So you saw the add here, right? What if I want to pass something a runtime? So let's do this. Console log calculator, and I'm gonna pass 4. I'm gonna pass 2, and then I'm gonna pass a function that I haven't defined here. Okay, this is where the arrow function comes in the picture, where I can say, okay, I'm gonna take some value and I'm gonna return it. So this is where it takes n1, n2, and then I can say n1 first multiplies by n2, and then minus 5 or something. Okay, I've created my own calculation that it takes 2 values and it transforms into this. See how this simple formula looks like, right? Where it takes something and I say, I was going to produce this. That's it. So this is our callback function, right? It's called inline callback function. I haven't defined this outside. I'm just directly passing this. And it's easier to do an arrow function. Otherwise, it looks kind of ugly. If I were to pass this multiply here, it would look ugly, right? So callback functions are neat looking things that you can just pass in. Let's see what it produces, right? So if I just console, if I just comment this out and run this, it returns 3, which is, it will multiply 4 multiplied by 2, right? Which is 8, minus 5 is 3, right? Or I can actually do this. I can return a string. Here I can say, I don't care about. Okay. So, you can do pretty much anything, right? It looks silly, but you will see lots of usage of this later on, and it's really powerful. It's a, you have probably heard of object-oriented programming, right? This is called functional programming, where you use function to pretty much do anything. And it's pretty cool. A lot of programming languages now supports functional aspect of it, and because sometimes object-oriented programming languages, they're very hard to understand. It has rigid rules, like you have to create classes and all that stuff. This stuff is pretty simple. It's all basically functions, right? So yeah, let's create a division, right? So use a calculator and then create another function. One time you can create a division where you just say n1 divided by n2, and then the second time you can just pass it as a callback function directly inline, right? So you get some practice. And I think once you understand these callback function, I'll guarantee you, I'm going to show you some really cool tricks that you can just use to do a lot of one-liners, right? And one-liners are basically, I want to remember we looked at how to add numbers, to create sums, and a lot of different things by creating using bunch of functions that are already available, and then just using them, to do cool things. Okay. Any question? Please create another function called division or something, which divides two numbers, right? And get some practice. Let me remember this. Simple. Just like calculator, there are already built-in functions, right? That that they have done. Here you can do a lot of things. Let's say if I want to build a function where it adds two numbers, I want to do something like this. Really kind of funky, where I want to, let's say, I want to do, let's say, add two numbers. And then multiply by subtraction of two numbers. Something like this. I'm gonna follow the, what is it called, pandas, right? Instead, I'm just gonna do this. I want to do something like this. Okay. I'm gonna use all three in one. Okay. And this is like, let's say this is a unique calculations. Why would I do that? I don't really care, but it's a unique calculations, right? So I'm gonna have F1, F2, and F3, right? F1 is basically, is this, F2 is subtraction, and F3 is multiplication. Let's assume that, okay? So what I'm gonna do is, I'm gonna first use F1, which is a sum, right? And then I'm gonna use F2, which is subtraction, let's say. Two is subtraction, and F3 is basically multiplication. So what I'm gonna do is F3. What it does, it takes the sum, right? And then subtraction, and then minus, and then it multiplies them too. All right. It's a weird looking formula. Okay, let's say if I want to build some unique a formula, then what I have to do is, I'm going to call it let result equal to unique. I'm going to pass obviously two numbers, which is 4 and 2. And then I'm going to pass add. Remember, add, minus, and multi. That's it, which will actually give me this, right? So add is nothing but gives me the 2, sum of this 2. Subtract would give me the subtract minus of this 2, and then both of them I'm going to pass into F3, which will multiply. So with 4 and 2, it will be what? 6 multiplied by 2, which is 12, right? I think it should give me 12. Let's see if it does. Let's see if it does. Okay, it gives me 12. So I've created this unique one that does kind of hodgepodge of things. Why would I do that? I don't know, right? So I'm just showing you the power of, I can build some mathematical formula using this kind of thing, right? And that's the beauty of this. It's basically, it's called composition, where I'm composing different things and creating it, right? One of the examples I say is, if you ever use object-oriented programming, right, where you create a class and then you inherit from it, and you create children subclasses from it, right? The problem with that is, let's say, and then the child, the subclass supposed to inherit properties from the parent, right? The problem happens when you want to build model where let's say your boss said, I want to build a human. Okay, I want to build a human, and he can eat, laugh, run, and all those activities, right? So you build a class that does that. Then you say, okay, now from that human, I want to build a class that is a Superman, which he can he can fly, he's got lasers in his eyes, and he's got a cape and all that stuff, right? Now normal humans don't do that. So building something like this would be very difficult, right? Because it kind of breaks a law of inheritance. So what you have to do is you can use something like this, where you can have human functionality, and then you can have super functionality, and then you can borrow some functionality from human and some from superhuman, and then you can create a Superman, right? Another example of this would be, let's say if your boss said, we're going to build a product called dog, right? And then dog can eat, can bark, and can poop, right? But then later on he says, oh, you know what, this product is not selling, we're going to build robot dogs. And robot dogs don't eat, they do bark, don't poop, but they fight, okay? And they have batteries. Now your whole model was around building something that is like a natural dog, so that's supposed to follow natural inheritance law. You cannot create a robot dog from a dog, right? Because it doesn't make sense. And that's where you have to build sort of like it's called composition model, where you take something from here, and then build something, right? And this is the composition model that you can do with functions, and mix it up, where F1 can be barking functionality, and F2 can be flying functionality, right?
Mr. Patel,
Yeah.
so for the unique function, right?
Mhm.
Wouldn't it be kind of irrelevant because like we can just run multiple functions on one line?
What if you this is a very simple example, right?
Oh, okay.
But imagine these things were like very complex, right?
Okay.
So,
All right.
and again, I'm just that I like to always show like a simple example. Like having an add function even doesn't make sense. I can just add n1 plus n2, right?
Yeah, I can see that. I was just
Right.
curious. So
Yeah.
do I really need to do that? Because like you can just put all in one line, you know?
Yeah. You can put on one line, but the objective here is to show, and I'm going to show you now. I'm going to show you a complex example
All right.
where we're gonna use this unique functions that are somebody else created, and we're just gonna use it for our own, and it would look so simple. Okay, so let's use that. So couple of functions that that JavaScript has already has created, and they're part of this array object. So let's say if I have an array called let's say nums equal to 1, 2, and 3, right? Remember, we looked at the example where we're trying to find the sum of the array, and we had this little function that we created. JavaScript provides this callback function. Says, okay, you know, we're gonna provide a mechanism to iterate through any array, right? So the mechanism is basically I would pass some sort of array, right? And I'm going to provide a callback function that transforms into a different kind of array of a same size. Okay, so you pass one array, and then you return another array. What you may want to do is you may want to double every element's value, or you want to do something else, right? But it doesn't matter. But you may need some functionality where you have an array and you return another array. How do I do that? Using a callback function. And these are built in JavaScript. So the way to call it is I'm just going to say nums dot, and the function name is called map. So basically this is part of this direct, you can just call directly on an array. And what the map function does, it says, okay, just provide me this transformation a callback function, and inside it does its own unique thing, right? Just so we show this unique, inside it does the unique thing. All you have to do is provide the functionality of what you're going to transform, right? So when you transform, you get individual element. Let's call it element, right? And remember, the callback function is basically this syntax, right? Where you take something and you give something back, right? So what I want to do for every element, I want to double the value, right? So 2 multiplied by element. Okay. So I've passed this callback function. Obviously, I can create this function and just pass into it, but I'm just doing the inline directly. So I don't have to really write this function at all, right? And I'm going to call it double. Okay, let's see what happens. Okay, it gave me 246. I don't really have to write any functionalities just to read every element and double it. I can just say map it and then pass me the formula for dealing with every single element. So mapping, inside the unique functionality of mapping is that it takes the element of the array and it takes its callback function, and it basically saying, okay, I'm just going to apply this transformation. So it's a very abstract function, right? If I want to do, let's say, multiply every element with another element, right? Which means this will be 1, this will be 4, this will be 9, right? I want to do that. There you go, 149. Okay, so map function really, I mean, you can do really magical stuff, right? You can see the application of this, right? So that's the one function, which is really great. It lets you, as I said, it takes an array and it returns the same size array, and it does some transformation. All you have to do provide is what you're doing with every element. So I'll say for every element, I'm, you know, multiplying the element with the same element. Okay. All right. That's a map. What about another function, so where it takes an array and then returns smaller array? Why do you want to return smaller array? Well, you want to remove certain things. You want to remove, let's say, I don't know, depends whatever you want to, whatever you decide what you want to remove, you decide that, and then it removes it for you, right? So let's see let's create this function. I would call it a filter, right? Because you're taking a longer array and then you're making a short array. So I'm going to call filter equal to nums dot filter. This function basically say, okay, provide me functionality of things you're going to keep. Everything else I'm just going to remove. So I'm going to take an element, right? And I'm going to say, keep everything, every element that is greater than 2. Okay. Which means it leaves me with only 3 here, right? Okay. Console log filter. Let's see what it does. Right? It leaves me with only 3. I mean, you can flip this. You can say, leave me anything that is less than 2. In this case, it will only keep 1. Right? So this is filter. And again, you can combine them too. And I'll show you how to combine them. Okay. So this is filter. The next thing we're going to look is you have an array and it returns one thing. It checks many things and it returns one thing or single item, right? Think of the total, right? Remember we said we're going to take the array. The total is a one example where you take all the element and then return the total. You can also do something else. You can return the maximum value or smallest value or average, right? Doesn't matter. But what you're doing is you're taking an array and returning one thing. And for that, you need a function, right? So I'm going to call it reduced, right? It's reduced to something 1. Okay, so I'm going to take nums as the array, and then the function that we have is reduce. And each of these functions, have a specific signature, right? For reducing, for filter and map is pretty simple. You just say for every element I'm doing something, right? For this one I'm doing something. This one I'm deciding what to keep, right? This is what to keep, right? And rest of things going to be filtered. This is how to transform, right? Because we are transforming each element, right? Here we are summarizing things, right? Or reducing it, whatever you call it. So here we're going to have actually multiple things. We're going to have an element, and then we're going to have this value. I'm going to call it total. Okay, I can name whatever I want, but I'm going to call it total. And I want to know, what am I going to do with each of these, right? So remember we had this, if I want to add everything, so I'm going to say element plus total, right? So take each element, have the total. So initially total is going to be 0, and it will keep adding for each element, and then it's going to reduce to the total, right? So let's say console log reduced. And this is going to be 1 plus 2 plus 3, 6. Here, spelling. All right, so you get 6. Remember, the first one, we get the full array. Second, we get a subarray, smaller size. And this one, we don't get an array, we get a number, right? Again, it could be anything. I'm just doing this. I can actually subtract this, right? And it will basically give me minus 6 or -4. You know why -4? Any idea?
Because you subtracted.
Yeah, but when I add it, it's 6. Why it's when I subtract it is -4? Because the first value is 1. So we're just saying 1 minus 2 is -1, and -3 is -4. Right? That's how it does it. Right. And there were so many things that you can do with it. You can also and this is kind of these 3 functions are very in nature. You find it a lot of things like this, right? Let's say if I want to build a burger, right? If I want to build a burger, what do I have? I have some ingredients, right? Like I have, let's say, onions. You have you have a ketchup, beef or whatever, meat, right? Let's say you have onions and meat, right? And then you're building a burger. So you have an array. Well, let's have pickles as well. Pickles. Okay, you have 3 things. You have onion, you have meat, and you have pickles. All right, the first thing you do is what? Cut all the items, right? So you need a transformation. You pass this thing, and then you say map it. When you map it, what do? You cut them up, or you grill it, whatever. You take something, but it gives you the same thing, right? So what it gives you is, chopped onions, right? It gives you cooked meat, right? Chopped pickles, whatever, marinated pickles, right? So you transform this. And filters, like some people don't like pickles. I want to filter it, right? So what I'll do is I'll take this array, and then I'm going to transform into only 2 items because I want to filter. I don't like pickles, let's say. Then I'm going to say, okay, remove filter out pickles. All right. And then I'm going to reduce to a burger, right? I'm going to take this, and this will return not an array, it will return a burger, right? So, and in nature, these 3 things you always do, right? You transform something, you filter something, and you reduce something, right? There are some other stuff, unique cases as well, but what you do, it depends on this function, right? So also cool thing is, let's do some practice. You can actually take the answer of one transformation and apply it to another one directly. So let's say if I want to double every element, let's say I just want to do exactly this thing, right? I want to double every element. I want to remove let's say 2 from the array, and then I want to create a total, right? So what I'm going to do is this, and this is really cool. Result equal to, take the array. First thing I'm going to use is transformation. So I'm going to map. I want to double every element, right? So I'm going to say take an element, And again, you can write whatever you want here, right? It just, and then I'm going to double it. The 2 multiplied by E. Then I say I'm going to filter it. I'm going to say E. Actually, I don't even have to write this. If it's a one thing, I don't even have to write this. Because remove 2. So I can say if E is keep what you keep. Keep if E is not equal, keep everything that is not equal to E is not equal to 2. So it will remove one, it will remove 2, keep 1, 1 and 3. And then I would say reduce. I would have the element and the total. And then I would say E plus T. You see the power of this? And then I can say console log result. If you were to build this, all of these, it would, take a lot of code, right? Because I have to iterate through every element. I have to do all of these. It's done for me. So this would be what? If I double every element, so it becomes what? 2, 4, and 6. If I filter anything that's not 2, 2 is not going to be in there, which means it will keep the same size of element. So 2, 4, 6, and I would add it, which means 2 plus 4 plus 6 is 12, right? So you'll get 12. Oh, you get a 10. Let me see, 2 plus 4 plus 6. Hold on, let me see, 2, 1, 2, 3, right? So 2, 4, and 6. All right, how is it getting a 10? Anyone? Because we are filtering 2, that's why. So it's only 4 and 6, that's why it's 10. Right. So in one line, I have doubled all the elements of the array. I have filtered them, and I have created a sum. How cool this is, right? There's actually JavaScript solutions for one-liners. It's really cool. All right, let's do an exercise. Let's say divide every divide by 5, filter odd numbers. Okay. And oh, you know what? Divide 5 and multiply by 5. Let's just say multiply. Multiply by 2. Filter even numbers. Okay. And then get the sum of all the numbers. Okay, the answer is 0, but let's see if you get it. It doesn't matter which array it is, the answer would be 0. If they are integers, which means they're full numbers. Okay, so multiply by 2, filter even numbers. Okay. And then sum of all, and then just use this line, right? Where just yeah. once you have a solution, put it in the chat, private chat. Yeah, filter even means keep odds, right? Be back in a few minutes. Just gonna go off. The second one is tricky. How to keep filter even numbers, which means keeping odd numbers. How to determine if something is odd or even. You can divide by 2, and if the remainder is 0, then you have an odd number. If it's non-zero, then you have if you have a 0, then it's an even number. If it's non-zero, then it's an odd number. The first class we learned that you know how you divide two numbers, 3 by 2. But if I want to just get the remainder, then I would just percentage 2. This would give me just remainder. Okay, so you can use something like this. All right, anyone? I think these two are the same, right? We're doubling it, we're summing it. This is the only one that you have to worry about. All right, anyone? Okay. You guys are very quiet today. Okay, we have 1, 2. Okay. All right, I like that. I like Benjamin's solution. Okay.
I do not want to put too much effort.
Yeah, I mean, I like your thinking process, right? It's when when you don't know the exact solution, you try to get close to it, right? That's how it works. So what he did is pretty interesting. Is so say if you filter the even numbers, so he basically did this. He said if it's not equal to 2, well, the whole syntax is a little wrong, but the concept is, he did this, right? If you were to do something like this, obviously you would have to say, you have to say this. and then you would say E not equal to 4, and so on and so forth. But I mean, yeah. So, but if your numbers are different than 2, 4, 8, 6, then it won't filter. So the best solution is you try to find a remainder. So if you divide that number by 2, and if the remainder is 0, then you filter it. Or in this case, you can say not equal to 0, right? Which means there is a remainder. So let's see. Okay, it says reduce of empty array with no initial value, which means this filters out pretty much everything, right? Because I intentionally did this. If you multiply something by 2, you're always going to get an even number, right? And if you filter all the even numbers, then you're not going to have any numbers, right? And then the sum would be then the 0, because you don't have any numbers. So there is actually in the reduce function, there is another, you can start with what sum you want, right? I can start with a 0 sum. And this is the syntax. And now if I run this, it will give me 0. So that's how this works. Again, it's pretty, this is very powerful. This is what I was talking about, right? Where you mix and match things and you can produce stuff. I mean, we haven't even touched the surface of it, but what this map function does internally is it basically takes a function. Again, as I said, it's a unique function, right? It takes a function, it looks at the array, it goes through that for off loop, and then it applies for every element, it applies a function, but it gives us this abstraction that we know that if I pass an array as an argument, it will return me an array. Right, that's what it does. Okay. So yeah, I intentionally gave you a little bit of a harder problem. But yeah, it's, as you can see, you can do so many things, right? Here I'm filtering out all the even numbers. I can filter out, numbers or strings. I can do a lot of different things, right? Yeah, it's really fun once you understand it. At least what you can do is whatever you wanted to do becomes very simpler, right? Because in one line, I can do so many different things, which was not possible before, because before you have to, write 3 different loops, right? To first double it, filter it, and then reduce it. Any question on this one? You're going to be using this a lot in React. So in a couple of classes, we're going to start with React, and you're going to be able to build games. And one of the things the map function would do is not only you can pass numbers, but you can actually pass the actual HTML elements. So let's say if I grab an empty element, HTML element, and I can transform it into a button, right? So somehow I can have an array of buttons or something, or array of pictures and things like that, right? So this map function is going to be very useful to transform something to something, right? I can, let's say this E can be a picture and I can put it in a frame, right? Or I can have, remove certain pictures or mush all the image together. I mean, you can do a lot of things, right? Here, we're just dealing with numbers. But once you get to React, we're going to be dealing with a lot of, like HTML elements and things like that. Okay.
Uh,
Go ahead.
so there's two E's in map, right? The first E is the array, right?
This E?
Yeah, that E.
Yeah, so basically map, yeah, there are two E's. The first E is basically every element of an array. Think of it in every element of an array.
Yep.
Right? So let's say I'm gonna just grab one element, which is 1, right? So if I pass 1, what would I get? I would get 1 multiplied by 2, right? Which means I'm doubling every element.
Oh, so that E is just representing every element.
Yeah,
in that
every
array.
element.
Okay.
Yeah, exactly. So because remember abstraction. In abstraction, you can say, I want to do something with every element. That's what it means. You
All
see,
right, I see. Yep.
you take an array and I return an array, which means I'm doing something with every element, right?
Yeah.
Yeah.
All right, thank you.
Yeah. So again, as I said, I can actually create an HTML element from out of this, right? Okay, let me just first copy this. Yeah, but good question. I think it's an important to know, right? If you understand the gist of it, right, you can do a lot with it. And programming is all about asking questions, right? What is E here, right? You can say, oh, E is every element. And then what it returning is it's taking every element and multiplying by 2. Here is taking every element and then deciding which element should stay, right? Which means if I divide this element by 2 and the remainder is not equal to 0, that element is going to stay. All other elements are going to be gone, right? In this case, it's saying take each element and add it to the total, right? And then what is the total initially? It's going to be 0. So this is the initial value, right? That's how it is. You can also do, remember I said, you can also do, if I want to, let's say, create HTML elements, right? Let's say button, series of buttons, for example. So I can say let me just remove all of these. You can say let buttons equal to, well, I just have numbers first. I have numbers. I just have yeah, let's just have numbers. I'm running out of ideas where I'm gonna have 1, 2, and 3, right? And what I'm gonna do, I'm gonna transform into an HTML elements, and each element's gonna have 1, 2, and 3, right? So I can say let result equal to, I'm gonna take nums dot map, and then I'm gonna say each element, which will be this number, and then what is going to return is button because it's going to be a string, right? So I'm going to have to wrap it like this. And then I'm going to put the E inside, right? So it's going to have button 1, button, button 2, button, things like that, right? If I console log this result, somewhere something is missing. Let's see. I'm missing something. That's strange. Oh, right here. That's one. Okay. It tells you whenever you try to format it, it'll tell you if there's a problem. It will not format. That's the one thing that, because the error was not clear. So there was an additional double quote somewhere. Right? So it created a array of buttons with the elements inside. Now, when we build React, this can be a visual interface. Let's say if I want to build, what is that game that we have? A memory game, for example, right? It's a good idea to look at it. Memory game. JavaScript. I want to build it. I want to see it. Oh, there's a code pen. Somebody already created, right? If I want to build this game, right? I don't want to build like this thing, this thing, this thing. I want to use a map function that just builds it. This is probably not built in React, so I don't know if it's going to have map function or not. It may or may not. I'm not sure. Let's see. But when you build in React, you would see it. Map, do you have map function? No, because it's not React. React usually allows you to do that. But anyway, I mean, you can see the code is all, you will see a lot of weird stuff here that you probably don't recognize. But as I said, if you want to build it in React, the code was going to be very clean. They have built this in JavaScript. So you can build something like this once you know React. So basically, if I click on here, this says JS, CSS, HTML, jQuery, right? I mean, you get the idea. Python, Node, JS is here. All right, so PS, I know where the SAS is. There it is.
One more to the left, SAS.
Oh, yeah, okay.
It's not cheating.
All
Yeah,
right. Yeah. You have good memory. All right, this is, oh, lucky. PHP. I don't remember where the node was. Oh, there's a PS here, I think. Oh, there's a PS here. PS here. PS here. I don't remember where the PHP was. I know where the Python is now. HTML5. I don't know where it was.
I think HTML was on the left, bottom left. Oh, nope.
Oh, this is Node, yeah. This is Rails. WordPress, okay, good. And my memory is so bad.
CS was in the middle. Yeah, that one.
Okay. I think this was PHP. I think, yeah, that's it. And then, so you can build this game. This is pretty cool, right? You can build this game. Obviously, you have to use, images and cards and stuff like that. But in terms of building that whole matrix, you can build using that callback function map. It's so easy. And then obviously you have to add the actions and everything. So callback, you're going to be using callback function a lot. What they have done is they're using something called just a pure JavaScript. Obviously, you can use callback function there as well, right? But they're not. They're using more functional things. You can see object and more functions, which is a one way of doing this. But this is much harder way. So you see they're using each. So instead, they could have used map here, right? So they are actually looping to the array and then doing the same thing that I did for the button, right? They're just doing the same thing. But this is a callback function, by the way. You see, is they pass this function inside a function as an argument. It's kind of weird way of doing this, but yeah. Cool. Yeah, I think that is it. As I said, if you I'll give you some good homeworks on callback functions, because they're so important to learn once we start doing React. It just you can't actually get around without using callback functions. So you're gonna like it. And next week we're gonna go through something called flex. This is also one of my. So flex is pretty interesting. Flex box, called flex box. Okay. Oh, this is my favorite. And we're gonna learn this. So flex box is basically, how most difficult part in HTML is placing things on the right location, right? So I have these two items, right? I think the objective is to put this frog into this box. I think so. So I need to do something. I can say, let's say justify content as space between, I don't know, let's just see. I don't know what the objective is, or flex end, I think maybe. I think the objective is, that's it, yeah. You see that guy went in. So the objective is anytime you see a frog and a box, you need to put it in a box. So this is a great game to learn. So now I want to put this box is inside, and I also want to put justify content, and this one would be center, I think. Okay, you see there now in the center. It's an interesting game. And I think this one would be last one. I'll just do justify content. I think it's space, but justify space. No space around. Yeah, space around. Anyway, so you see what they're trying to do is, like, if I have a bunch of elements and I want to place it exactly like these circles, right? The frogs are the elements that I want to position, which will go in the circle. So these are the commands that I can use to place it. So when you build a game, right, you will need to understand how to put things in a different order, in a different row. It could be all mushed together, or it could be space apart. And so there are lots of different options, right? This will teach you, again, I'll show you how, but this will teach you how to do this, and it's pretty fun. Once you learn Flexbox, you can do a lot of HTML layouting, right? A lot of people don't know how to do layouting, let's say if I want to build something like this whole thing, right? I need to put this green area on the left side and a blue area on the right side, and then this on the top, this on the middle, this on the left, right? Or bottom. People have hard time, doing this. Flex makes it very simple. So next lecture, this is the only time we're gonna learn some HTML stuff. We're just gonna learn Flex to put stuff in the right place, right? Once you can do that, we can build games, right? Let's say if I want to build a memory game, I would need to put all those boxes in that nice matrix. Flex will let me do that. Okay, so yeah, next time will be that. We are almost at the time. Any questions on this one? And then we will, week after that, we'll move to React. All right, cool. That's it then. We'll see you guys next week, and have a good week and the weekend.
Thanks, Martel. Have a good day.
All right.